Hello there everybody, hope you're all doing well. This is Amlan Panigrahi from NUA and we are back with yet another video of Jetson Nano after a really long time. So today we'll be covering about DeepStrem SDK 5.0 which will be executing on Jetson Nano. It's a developer preview version and we'll be talking a bit about Transfer Learning Toolkit 2.0 which is also a developer preview version. The final release, the production release are yet to be launched by Nvidia. So what is this DeepStrem SDK? So if you recall from one of our past videos, we covered a bit about it. We did some examples. So as the name suggests, in simple words, it is a deep learning streaming analytics toolkit. So we'll be basically, our focus will be more into DeepStrem. In this video, we'll be doing a practical example. And for now, just let's talk a bit about Transfer Learning Toolkit. So basically it's a collection of pre-trained models made available by Nvidia such that you to facilitate agile computer vision model training when you have relatively a small data set and when you need zero coding knowledge and when you don't require knowledge of existing AI frameworks. It's made that simpler for you and that's really amazing. We'll be definitely covering about a Transfer Learning Toolkit tutorial and just to be just to keep you informed, you can integrate Transfer Learning Toolkit in DeepStrem as well. We'll be talking about that, yes. So why do we need DeepStrem SDK? Consider about a scenario. Suppose you want to monitor traffic insights, real-time insights. So let's say you have trained your model on another platform, a high-performance computing platform, and then you have deployed that model on a tiny edge computing device for just inference results. So it is connected to a camera in some part of the city and it is capturing the live feeds, and at the same time it is doing the predictions and it is broadcasting the real-time analytics to any cloud platform. It can be anything. So the processes involved here are many: data security, message broker, communication between the source and the destination application, and a pipeline. Basically there is a pipeline involved here, and of course we are talking about the broadcasting part, right? It is not that simple. So basically what would you do naturally in these scenarios? You would either code everything from scratch, obviously you don't want to do that, or you would rely on a variety of different third-party applications for the specific tasks involved here. Now thing is that is again split into different processes. They are happening differently. Now what DeepStrem does is basically, if you have your Nvidia GPUs and you are computing on those platforms, they have this amazing this Streaming Analytics Toolkit that bundles everything together into one single workflow. You don't have to code, you don't have to worry about third-party applications. Everything is bundled and you just need to edit a config file. That's it, and it does the job for you. How about it? Do you like it? Let's discuss some of the key highlights of DeepStrem 5.0. Remember that there are really very cool and interesting features that come up with DeepStrem 5, but we will be discussing about the top 5 features which I feel are more intriguing on a personal note. So what are they? Point number 1, they have added support for don't mind me, I really like this logo here, so I'll just get it there. Yeah. So point number 1, they have added support for Python development. Now you can develop DeepStrem apps with Python. So basically what happened was embedded AI, embedded high performance computing demands you to basically code in C or C++ by default because they are really very fast. Python is a bit slow because it is built on top of C, but anyways, they have right now, Nvidia guys have added the support for Python, which is really a huge boon for many people, a whole lot different larger community, and this is awesome, super awesome. And the next, they have added extended support for YOLOv3, you only look once object detection. And then point number 3, dynamic model update on the go. The words speak for themselves. I guess you can figure it out. Point number 4 being they added a smart record feature. So what basically you can do with it is, instead of recording the whole live object detection, you just want to record the important parts in the video, right? So the smart record feature is at your disposal, man. Use it. So I hope we covered everything out. And yes, how can I forget? Point number 5. They also added support for the all-new Jetson Xavier NX, the successor for Jetson Nano. You really need to check out this product. It's really awesome and interesting. Check the link that's mentioned. And cool, we are done. Let's explore some of these features then. Let's get to the most important part that you have been waiting for. So now we'll be implementing a DeepStrem SDK with YOLOv3, and let me first tell you that it was quite challenging for me to find a perfect guide where there are a set of instructions on how to integrate YOLO with DeepStrem SDK. But thankfully, all thanks to this guy, the Marcos, his repository on GitHub helped me to do so, because for DeepStrem 5.0 I couldn't find anyone who updated the repository, an updated repository about the necessary things that you have to do get YOLO up and running. So you can also definitely have a look, and we won't be going through the steps of how to get it running, the initial ones, and just visit this repository for reference. And I want to highlight this fact that what most of the people are doing, the YOLOv3 support is like existent in Jetson Nano since quite a long time. It has been almost a year. But thing is, what people are doing is, instead of integrating YOLO with DeepStream, they are installing it via, they are doing the Darknet installation separately, and the performance that they're getting is not so cool. In fact, it is, I don't want to say, but it is pretty bad actually. In fact, you can see it for yourself. So this is a DeepStream 4.0 comparison of the YOLOv3 tiny model execution on Jetson Nano. So basically the DeepStream performance has been compared with the Darknet performance. So we'll just run it a bit. So as you can see on the left hand side, it is the DeepStream version. Like, there are multiple windows of the same input video file on which the Jetson Nano is doing the inference. So on the left hand side you have the DeepStream version of YOLO, and on the right hand side it is Darknet. So you see the performance is pretty much smoother here, and the frames per second are like in the range of 20s and 30s. Yes, average is 28 here, it's 32.6 here, and in fact this is, I guess, floating point 16 execution. And so here on the Darknet side, what do we see? Oh my god, this went black. We'll talk about it, why they went black. So on the Darknet version, you can see the object detection is happening, you can see the labels, but the frames per second are much poor here, almost like Jetson Nano exhibits a 2x better performance. So why did this go dark here? Because the inference is over already on this side, and the inference is still pending on this side, which is quite hilarious. So why not try DeepStream, man? Go for it. I know it's a bit challenging, but you can get this up and running. There are some guides. So now what we'll be discussing about is like the most important part is like how to install DeepStream SDK, right, on DeepStream 5. So which I forgot to tell you. So not to worry. What you need to do is just go to the Nvidia official website. Now know that there are two ways in which you can get your DeepStream SDK up and running on your Jetson Nano. One is by a Docker image and the other is by building from source. So with the Docker, basically you can get started with using the DeepStream within a few seconds. You just need to pull the Docker image from the official Nvidia site and you can just use it for your deployments, and you can in fact scale it up and deploy it in multiple platforms. It is quite useful as well, but keep in mind that there are also some hiccups involved because DeepStream SDK, the Docker version of DeepStream SDK won't detect camera just like that. You have to mention some additional commands. On the other hand, building from source requires you to do some additional steps, but it is quite easier. You just have to install the prerequisites, packages, and you just have to install the DeepStream SDK. The steps are mentioned. Do refer the guide. The link is there in the description. And that's what we exactly did. And we are going to show you that. We also ran the Docker version as well. It also worked. But our focus will be on building from source. So what you need to do is you just need to go to this repository. I mean, not repository. I mean, go to this folder. Just using a terminal, head to this directory where your DeepStream is basically. So OPT Nvidia DeepStream, DeepStream 5.0 sources. So what is this custom YOLO folder? So this is like a custom folder that we created to deploy our own custom app, our own custom DeepStream app, which is of the YOLO one. So the steps are mentioned in the repository by Marcos. Do have a look. We are not going to get into that. So basically what you have to do, the gist is you have to copy some files from the default object detection YOLO folder presented in sources. And then just copy them to this folder, custom YOLO folder. So what are the contents of this folder? As you can see, we already listed it in this step here. So it has a config inference file, it has a labels file, it has like an engine, and there is a DeepStream config file, and there is again one folder where basically your C++ files are there, and the compilation has been done here. The main program files are here in this folder, and of course you have the weights. And let me tell you one more important fact, that the YOLOv3 tiny PRN is the best one that you can find. You can execute on Jetson Nano and you can get a much better performance, which is tried and tested, and it is none other than Marcos who pointed this out. So without any moment of delay, one more important fact. So if you remember, we made this awesome JetVengers project with Jetson Nano where we did a live object detection of action figures. Let's have a small rewind.
So now you see
so
that the OpenCV
basically what we did here was like we did the processes manually. We first trained the model in Google Colab, we saved the model, and then we copied the model into Jetson Nano, we deployed it there, and then we had to convert it into the TensorRT compatible model. So there was a conversion step involved, and after that we ran our code and did the inference. But yes, we also had to mention a GStream pipeline basically. So the GStream pipeline basically most of the people use this for embedded softwares, I mean for embedded devices, and in fact not only embedded devices, but when you try to execute you run a live video through a camera, this pipeline gives you basically a butter smooth performance. So it can be quite challenging for more people for getting the right set of arguments for creating the pipeline. But let me tell you that all the processes that we did, if we in that JetVengeance project, if we could have invested some time for the DeepStream version, maybe we could have got better results, because we don't have to convert our model into a necessary format. It's done for you. There is an engine file that takes care of everything. DeepStream takes care of it. You don't have to bother. In fact, the creation of the DeepStream pipeline, you also don't have to bother about that, because all the steps are done for you. All you have to do is edit the DeepStream configuration file, which you just saw. So let's have a look at its contents. So you can just do a VI, or you can do a gedit, whatever suits you. We are going to do a VI. So let's have a look at its contents. As you can see that there is this, there are some square brackets and some properties there, like application, source, sync, OSD, stream marks. So basically, what are these? These are various types of groups. And under these groups, you have to mention the necessary, there are some parameters, there is a key and there is one value. So these are basically the properties, and you have to basically change the values, and that's it. So we are going to focus on some of the important stuff here, like the source group basically. So what is this source 0? So source 0 says that, so if you want to have multiple sources, so you will refer them by some number, right? Source 0, source 1, source 2, source 3, 4 different sources. So this is one source of your input for Jetson Nano Inference with with YOLO. Is it live camera feed, or is it an input video file, or it is input video file from a link? So you have to basically mention the necessary parameters for the same, for here, like for example here the enable equals to 1 is a boolean value that says basically to enable this source, and there are basically 5 types. So 5 types of the sources. One is your camera V4L2, which is for USB devices. 2 equals to URI. URI basically you provide a path. It can be a URL, or it can be a local path as well. And 3 equals to multi URI. So if you want to mention multiple sources, multiple URLs, you have to go for this. The other 2 are not mentioned here, but that's like this. So 4 is your RTSP, which is like for a real-time streaming protocol, and then the 5th one is for CSI cameras. So that's all. You mention your camera width, camera height. We have set it to 640 into 480, and the FPS, and the dev node. Basically, this is the device number, and the smart record feature, which you already discussed. The necessary properties for this, you mention them here. And then you have this sync. What is sync? Sync is basically if you want to make some changes in the decoding and encoding, the render, the properties, and the output path, you do that here. Similarly, you can check the guide for editing the configuration file. The link is mentioned in the description. Do have a look. So that's all. We'll move to the next file. Here, let me quit this one. Okay, so what is the config inference file? So config inference file, basically you are to mention the necessary configurations for your model, your YOLOv3 model here. So as you can see, the necessary arguments here are like, you know, the model color format, what's the model file, you know, for us it's YOLOv3 tiny PRN, and the necessary model engine file, and the network mode, of course, like whether it's floating point 32 or int 8 or FP16 mode, the different types of precisions here. And just refer the guide for you know, how to change these values, what to change. In fact, Marcos has also pointed out in his repository. Oh, okay. So what do we need to do now? Let's you know, execute our sample DeepStream application, a custom DeepStream applications that we made. So what we'll do is we will do a live object detection with our USB camera. Let me just set my camera a bit. Okay, we are cool. So what's the necessary command for this? All you have to do is use this command, DeepStream app -c, and the name of your file, basically the name of your config file. For us, you can see it's DeepStream app config YOLOv3 tiny.txt, and it's highly preferable if you execute it from the same folder. For us, it is custom YOLO. So let's run it. It will take some time to load up. Just a second. I have a hunch. Oh, something popped up. Okay, cool. So I'll just yes. You see the bounding box on me? Okay, cool. Now just we'll do on this cell phone. Let's see whether it detects this or not. Maybe I'll change the angle. Okay, I guess light problems. So this is a custom okay, see, there's a bounding box on cell phone as well. So this is just a custom model implementation. We did not train this, it was already available. This was a pre-trained model. Definitely, like if we have our own data set and we train on top of this, we'll get better results. Anyways, let's just see what is popping up in the terminal. Okay, just give me a moment to settle down. I'll close this. So as you can see, this is the performance on the live object detection. So we got a max of 17 frames per second. Maybe because this is live, you know, the input was live source, and on top of that it's a USB camera. That's why we are getting this type of result. But if we run this for you know, a sample video, an input video, maybe we might get better performance. Let's check it out. So now we'll be providing some input video files for the necessary inference with DeepStream YOLOv3 application. So like I have basically changed the input file here, the URI, you know, like it says street traffic h264.mov. We'll see the stock footage. I downloaded stock footage basically, and so we'll, you know, try to update some of the features here. So that's the source group for you, source 0, and then we'll see the sync group, sync 0, which corresponds to the necessary source. So type equals to 3, no, let's make it type equals to 2 for the ETL sync overlay, and necessary sync equals to sync 1 is not required, fine. OSD, so if you want to beautify some of the elements of the you know, like overlay, the bounding boxes, you can go ahead with this. So border width, let's add some thickness to it. I'll make it 10, and text size maybe 16 or not 167, and
and text color, I guess that's fine. Why not let's update the bounding box color. So as you can see, there are color 0, color 1, color 2, color 3. This correspond to the necessary classes. So I think the first class is person, class 0, class 1, class 2 and class 3. Okay, cool. So let's like add. So this is in RGBA format. A stands for alpha. So you can modify the color any way you want. I specifically want the cars in the green format. Okay, the neon color. Okay, it's already there, red green combo. Okay, cool. Okay, let's execute the sample DeepStream application. Can't wait to see the inference results. Okay, so as you can see, this is actually a stock footage of San Francisco street. So it's you can see the results here. The bounding boxes are accurate. Car, bus, person, bicycle. That's great. Car, bus, truck. Okay, car, person. Okay, that's nice. This is beautiful, man. Hey, see, that's a person over there. So we'll just check over the frames per second. So it's pretty much like it's decent, around 30 FPS you can say. So now we'll try to run over a different input file, the streets of Kuala Lumpur, the capital of Nepal.
Hey, what happened?
Music.
Kuala Lumpur, the capital of Nepal. So this is the necessary footage. I'll just edit the URI. Where is our source 0? Okay. Let's run the DeepStream app again. So you have the streets of Kuala Lumpur. Okay, it's correctly crediting this as bus. Okay, that's wrong over there. It's saying that it's a car, but it's a bus. That's fine. Motorbike, car, person. Oh, that was cool. That is pretty cool. So that's it. You saw like two video inputs there, and the inference results were pretty much decent. They were good. They were damn good. So that was really pretty exciting, and now I would basically like to talk about one loophole that maybe Nvidia has not looked into. So what is this basically? So what like if you have a USB camera, what you will notice is there are two types of formats, input formats that can be read by your Linux system. Your let's say your Jetson Nano. So one is UV format and another is MJPEG. So I found this in the forums and it was something interesting to look into. So what the problem here is, so if you have a closer look, so the UV format accepts all sorts of resolution, but the frames per second processed is there the numbers are very low. And compared to we want the MJPEG format. Now the flaw with DeepStrem SDK is like what we found out. By default, DeepStrem reads the camera input source, the format as UV, which means the processing will be much slower. You will see 6 frames per second, like the frames per second capped to 6, 5, something like that, and that is undesirable. So in order to bypass this solution, Nvidia engineers did reply in that forum itself, the user who faced this issue,
in order to bypass this, basically what you have to do is you have to go to YOLO.cpp file in your custom YOLO folder, and you have to add some additional arguments. Basically, you will have to link some variables. You have to create a JPG variable and you have to add it to the pipeline and you have to link them. So the problem here is basically those who don't understand C or C++, they will have a difficult time what to do and how to implement this. So that's not what you want, right? And we found out that this issue was in DeepStream 4, and we also found this in DeepStream 5, which means Nvidia may have not looked into this. So those who have USB cameras, like, it's my request to Nvidia that please look into this specific issue faced by USB camera users, so that they don't have to really go to the YOLO.cpp file and make the changes. Please add the update for that. So that's all. Like DeepStrem SDK, the developer preview version is still looking great, and there are a lot of additions, and the smart record feature was really something amazing, and the development with Python is something worth looking into, and we'll definitely revisit this in the future, maybe another video. And DeepStream is a vast topic, to be honest. Maybe we'll have to do 3 to 4 videos, in order to explain properly, line by line, what the configuration file means and how you can design your custom DeepStream apps, how to use the smart record feature. There are lots of things to explore. So we'll definitely look into that in the future. We have one request, from your side. Do share your feedback about this video and what you want us to cover in the near the upcoming future, and we would love to explore further. We would love to make new content. Don't forget to like, share and subscribe our channel. Thank you.